children. So today we'll start trigonometrical ratios. Before we try to understand what are trigonometrical ratios, let's see what we mean by trigonometry, because it's a new branch of mathematics for class 9. Okay, so trigonometry is study of relationships between sides and angles of a triangle. Okay, so in trigonometry we study the relationship between sides and angles of a triangle. In geometry, you know, we have the relation between sides or between angles only. Okay, so here we study the relationship between sides and angles of a triangle. Okay, so let's take a right angle triangle. Okay, let OMP be a right triangle at M and POM be theta. So we take this triangle, okay, OMP, to be a right angled triangle, and right angle is at M. Okay, then we denote this angle by theta. Okay, it's a Greek letter theta. Okay, so with reference to this angle theta, okay, the side opposite to this angle of this is called angle of reference. Okay, the side opposite to angle of reference here is called PM, which is PM, is called perpendicular, and we represent by small letter p. And the side adjacent to this one, okay, angle of reference, is called base, and the side opposite to right angle, that is called hypotenuse, which is the longest side of the right angle triangle. So we represent P perpendicular by P, hypotenuse by H, and base by B for our convenience. Now there are three sides. So if you think of the ratios, altogether we can make 6 ratios. Okay, like we can take perpendicular by hypotenuse, that's PM by OP one ratio, OM by OP another ratio, PM by OM another ratio, then their reciprocals will be 3 more. So altogether there are 6 ratios. So let's take the first one, the ratio of two sides PM by OP. Now PM is perpendicular, P, and OP is hypotenuse, that is H. Okay, so this ratio of perpendicular to hypotenuse is called sine of this angle of reference theta. This is called sine of theta, and in short we read this as sine theta, and we write sin theta. Okay, sine theta. So it's a short form of sine of theta, that is sine theta. Similarly, and the ratio OM by OP, OM is base, OP is hypotenuse, so B by H is called cosine of theta. In short we call it cos theta. Third ratio, PM by OM, that is PM by OM, that is perpendicular by base, ratio perpendicular to base, that is P by B, is called tangent of angle theta, and in short we call it tan theta. Then reciprocal of 1, here this is PM by OP, now its reciprocal will be OP by PM, so that is H by P, is called cosecant of theta, that is cosec theta. Okay, so next ratio OP by OM, that is the reciprocal of number 2, OM by OP, so that is called secant of theta, that is called sec theta. So OM, now last ratio OM by PM is equal to B by P, okay, ratio of base to perpendicular, that is called cotangent of theta, in short is called cot theta. Okay, now so we have 6 ratios which are called sin theta, cos theta, tan theta, cosec theta, sec theta, and cot theta. These are called trigonometrical ratios. Okay, so now we write the formulas now. Number 1, trigonometrical ratios. Okay, so in short we write, so we have sin theta equal to, now we have got P by H, okay, cos theta equal to B by H, and tan theta is equal to P by B. Okay, and the reciprocal cosec theta equal to s by p, sec theta is equal to reciprocal cos theta, that is s by b, and cot theta, which is reciprocal tan theta, that is called b by p. Okay, so for convenience, for easy to remember, okay, we can remember one sentence, that is, some people have curly brown hair turned permanently black. Some means for sine, people have means p by h, curly means cos, brown hair means b by h, turn means tan, permanently black means p by p. So it is some people have curly brown hair turned permanently black, means some is sine is equal to p by h, cos is b by h, and tan is p by b. So this way you can remember the formula. Okay, some people have curly brown hair turned permanently black. Okay, now number 2, reciprocal relations. Reciprocal relations. Now you know sine theta is p by h and cosec theta is s by p. So therefore sine theta into cosec theta is equal to, you know, sine is p by h, cosec is s by p. So when you multiply p by h and s by p, what you get? You will get cancelled, so value will be 1. Okay, so sine theta is reciprocal of cosec, cosec is reciprocal of sine, so their product is 1. Okay, so this will give you, so this will imply sine theta equal to 1 by cosec theta and cosec theta equal to 1 by sine theta. So sine is reciprocal of cosec, cosec is reciprocal of sine theta, and their product is 1. Similarly, cos and sec also, cos theta into sec theta, cos is b by s, sec is s by p. So when you multiply, the product is 1. Okay, this will give you cos theta is equal to 1 by sec theta, and sec theta is equal to, you get 1 by cos theta. These are called reciprocal relations. Okay, now number 3, quotient, Q-U-O-T-I-E-N-T, quotient relations. Okay, now if you divide sine theta by cos theta, so what you get here? Sine theta is p by h divided by cos theta is b by h. So h is cancelled here, so p by b. So p by b is actually what? P by b is tan theta. You can see here p by b is tan theta. So sine theta by cos theta is equal to tan theta. Okay. Similarly, cos theta by sine theta is equal to, cos by sine will be reciprocal of tan will be cot theta, because cos by sine will be b by h divided by p by h. So h is cancelled, so b by p you get, b by p is cot theta. Okay, these are called reciprocal relations. Okay, now we take very important set of formulas called square relations. Okay, number 4, square relations. Okay, number 1, now we have sine square theta plus cos square theta, the value is 1. Okay, so actually you know, in a right angle triangle, p square plus b square equal to h square. Okay, so if you divide both sides by h square, then we get p by h whole square plus b by h whole square equal to s by h and its whole square. Okay, so dividing 4 by h square. So p by h is sine, that means you get sine theta whole square b by h is cos theta, so cos theta whole square is cancelled, so 1 square is 1. And instead of writing sin theta whole square, for convenience, how we write it? We write this as sin square theta plus cos square theta equal to 1. So remember, sin square theta is actually sin theta whole square. Cos square theta means cos theta whole square. For convenience, we write sin square theta and cos square theta. Okay. So sin square plus cos square theta equal to 1. Similarly, from here we can derive few more formulas, like sin square theta will be 1 minus cos square theta, because cos square goes that side, becomes 1 minus cos square. So you can use this formula to change sin into cos or cos into sin. Okay. Similarly, cos square theta will be equal to 1 minus sin square theta. When sin square goes that side, it becomes 1 minus cos square theta. Similarly, we have got two more sets. Other one is 1 plus tan square theta is equal to sec square theta. Okay, therefore you get sec square theta minus tan square theta is 1. When tan square goes that side, becomes sec square minus tan square, 1 will be left. And tan square theta will be equal to sec square theta minus 1. So when 1 goes that side, tan square becomes sec square minus 1. Then we have got one more set, 1 plus cot square theta equal to cosec square theta. This gives you cosec square theta minus cot square theta equal to 1, and cot square theta is equal to cosec square theta minus 1. So remember, sin square theta plus cos square theta equal to 1. Theta may be any angle, doesn't matter. Okay, whatever may be the value of theta, the value is always 1. Similarly, sec square theta minus tan square theta also 1, irrespective of value of theta. And cos square theta minus cot square theta is also 1. For sin cos it is plus sign, sec tan it is minus, and cosec minus cot it's also minus sign. Okay, these are called square relations. Now let's see the application of these formulas and concepts. Okay, so we'll take question number 1. Okay, we are given a right angle triangle. Okay, this is right angle. This symbol is for right angle. So angle is given theta here. This vertex is O, M, and P. And the length of this OM is 12, and the length of this OP is 15. Okay, so given OM is equal to 12 and OP is equal to 15. Okay, so we have to find the values of all the trigonometric ratios. So to find all the ratios, we need to know the length of PM also. So how do you find the length of PM? You know it is a right angle triangle, so we'll use Pythagoras theorem to find the value of the third side. Okay, so by Pythagoras theorem, you know Pythagoras theorem says the longest side is square, meaning hypotenuse square is equal to sum of the square of other two sides, that is PM square plus OM square. Okay, longest side square is equal to sum of the square of other two sides, that is Pythagoras theorem. So OP is given 15 here, so 15 square equal to PM is not known, so we have to find PM square, OM is 12, so 12 square. So 15 square is 225, 12 square comes this side, minus 144 equal to PM square. This implies PM is equal to now 5 minus 4 is 1, so here 12 minus 4 is 8, 81. So this PM square equal to 81 implies PM is equal to root over 81 equal to 9. We take positive because length is always positive, so 9. So now we have all the three sides. The first thing, so whenever you have to find the values of the ratios, make sure that you know the values of all three sides. Okay, then Now we'll find the values of all the ratios. So therefore, first one, sine theta, because angle of reference is theta here. Now sine theta, remember, some people have, means P by H. So P is PM by H is OP. Sine theta is some people have P by H. So PM is 9 and H is 15. You cancel by 3. So 3 3 is 3 5 is. So it is 3 by 5. Okay. So cos theta equal to curly brown here, B by H. Base is OM and H is OP. Remember, this is perpendicular, this is base, and this is hypotenuse. Remember. Okay. Some people have curly brown here, B by H. So OM is equal to 12 and OP equal to 15. So if you cancel by 3, she will go 4 5 times 4 by 5. This is cos theta. Similarly, tan theta. Tan is turned permanently back, P by B. That is PM by OM. That is 9 by 12. So cancel by 3, 4. So that is 3 by 4. Okay. Now cosec theta. Cosec theta, cosec is reciprocal of sine. So PM by OP becomes OP by PM. So it is 15 by 9. So it is 5 by 3. Reciprocal of 3. Sine is 3 by 5. So cosec will be 5 by 3. Similarly, sec theta is the reciprocal of cos. So OM by OP becomes OP by OM. That is 15 by 12. So this is 5 by 4. Cancelling by 3. Cos is 4 by 5. So sec is 5 by 4. So finally, cot theta. Cot is reciprocal of tan. So PM by OM becomes OM by PM. So OM by PM will be 12 by 9. So it will be 4 by 3. So these are the 6 trigonometrical ratios. This is how we find the values. Okay. So now we'll take one more question today. So let's see what are given. Question number 2. So here we are given one more right angle triangle here. This is 90 degree here. Okay, this is A, B and C. This is 12, this is 5, this one. Okay, now remember the side opposite to this right angle is hypotenuse, so H we have to find out. Okay, we can take this as P and take this as B. P and B, it doesn't matter which one you take. Okay, H is important. Remember, H is always opposite to right angle triangle. So now here, to find out which is perpendicular, which is base, let's see what is the angle of reference here. Okay, from the given figure, sine A cos A. So angle of reference is A. So this is the angle of reference. So opposite to this angle of reference, we take it as P, and the other side we take as B. Remember, perpendicular is opposite to angle of reference, H is opposite to right angle, and B is the third side. Okay, so write given. Here OM is equal to 12 units and OP equal to sorry, OM is not given here. Here we are given BC equal to 5 units and AC equal to 12 units. Okay, we have to find AP, which is hypotenuse. So once again, to find the third side, we have to use Pythagoras Theorem. So from Pythagoras Theorem, so we have AB square equal to we have BC square plus AC square. You know, longest side we have to keep in one side, sum of the square of other two sides on the other side. Okay, so AB square we have to find out. So BC we have got 5 square, BC is 5 and AC is 12, so 12 square. So 25 plus 144, that is 169. So therefore AB is equal to root over 169, that is 13 units. Okay, so we found all three sides 13. Now question number 1. We have to find the value of sine A. So sine A is equal to angle of reference A here. Some people, that is BC by AB. So BC is 5 and AB is 13. So we can simplify further. 13 is prime number, also 5. So that's the answer. Next question is number 2. We have to find out cos A. So cos A is equal to, we have cos is curly brown here. So B by H, that is AC by AB. Because this base hypotenuse. So that is 12 by 13. Number 3. We have to find the value of sine square A plus cos square A. Sine square A plus cos square A. We know sine square A plus cos square A is 1, but then we have to find the value. So sine A we have found here 5 by 13. So 5 by 13 whole square plus cos square A we have got 12 by 13 and whole square. Okay, because sine square A means sine A whole square. So this is 25 by 169 plus 144 by 169. So if you take LCM, you get 169, and this is 25 plus 144 equals to 125 plus 144 is also 169 divided by 169. So it is 1. So answer is 1. Now the last part, sec square A minus tan square A. Okay, so number 4, it is sec square A minus tan square A. Now sec A is the reciprocal of cos. So cos A is equal to 12 by 13 means sec A will be 13 by 12 whole square. Okay, so tan A is sin A by cos A. So sin A is 5 by 13 by cos A is 12 by 13 and its whole square. Remember, sec is reciprocal of cos. Sec cos is b by s, so sec is s by b. So s by b. So 13 by 12. Tan is, you can also write directly, tan is turn permanent back, p by b. So p by b. So it is 5 by 12. This way you can write. Sec is s by b and tan is p by b. Okay, 5 by 12. So if you simplify, you get 169 by 144 minus 25 by 144. So this is 169 minus 25 by 144, taking LCM. So 144 by 144. So answer is 1. So you know sec square A minus tan square is also 1. Okay. Thank you, class.